Okay, thanks a lot for coming to my talk. My name is Mario Fusco. I'm from Italy. I work for IBM, mostly work on the Quarkus team. And of course, these days I'm working on the AI side of the Quarkus team because otherwise you are doing wrong. So I mostly work on the long chain for chain integration. But I'm here today to talk about something totally different. Okay, so uh, two economists are walking down the streets. One of them says, look, there is a $20 bill on the sidewalk. And the other economist says, no, there is not. If there was, someone would have picked it up already. Okay, and this is really probably a stupid joke, but this is the essence of the efficient market hypothesis. I mean, the market are efficient, there are no free lunches, everything is priced at it should be, and it's impossible to constantly beat the market. And this idea was there since the beginning of the stock markets, since the end of 19th century and the beginning of the 20th century, but they were better formalized by Eugene Fama at the School of Chicago in the 60s. So he better formalizes this hypothesis, saying that the market are rational, that there is no bias in investor, they are completely rational, and that money is fungible. Okay, but one decade later, somebody, especially these two guys, started finding another different hypothesis that better fit that, or at least take count of the human behavior. We are human, we are not machines, we are not robots, we have cognitive biases, and these biases affect our decision making. So they are starting to study how these biases affect our decision in the fields of the economy mostly. And the idea of this talk is to check how these biases not only affect our decision in the economic field, but in our day-to-day job as software developer. Okay, so the idea is that the human of Eugene Fama was the super rational econ. I feel of being closer to Homer Simpson than to Dr. Spock. I don't know about you. But in essence, they found a lot of biases. They classified it. They demonstrated it with experiments. And in essence, what a bias is a thinking pattern that makes us to make systematic mistakes. And when I say systematic, I mean that it's not a personal thing. I mean, I'm not doing systematically that mistake because my brain works that way. We all do those same mistakes exactly in the same way at little degrees, but exactly in the same direction, because we are human and because our brain is wired in this way. Okay, so I of course try to study a bit about this topic. I learned a few from these books. If you are interested, I can suggest you them, but there are many other books on this topic. Of course, the first one is written by Daniel Kahneman, who was one of the two person who started this research again in the 70s. Okay, so again, the idea of this talk is to check these biases in the real world and then figure out how they are applied to our day-to-day work. Okay, so the first one is what I called it patternicity. The scientific name of this thing is apophenia, but it means that we try to recognize, our brain is wired to recognize meaningful patterns even when there is nothing to recognize, even if it is just noise. So this is a quite famous picture of the surface of Mars. Of course, we can't help but seeing a face in this picture. Of course, the face is not there. Okay, our brain decide that there is a face on the surface of Mars. Of course, it's not there. And we see patternicity a lot. For instance, if you follow a bit the stock markets, you see lots of people trying to find pattern in the stock market quotation. I found this very this graphic on the internet, which is supposed to be serious by the person who wrote this, but to me it's simply fun. I mean, he's saying that there is a pattern where the market goes down during the lunch hour, and then there is for some reason it goes up at the end of the day, and he's following this pattern. He recognized a pattern in this thing that is just noise. And this is quite common, right? I don't know if you know this website. It's quite famous, but it's a website that finds spurious correlation between things that are completely unrelated, of course, like the number of movies of Johnny Depp and season wins for the Los Angeles Chargers. But apparently there is a statistical correlation between these two clearly unrelated things. So there are lots of this spurious correlation, and we find patterns out of them. And we, of course, find pattern in our day-to-day work. We attribute bugs to coincidental code changes. We do a code change, and then something goes wrong or something goes lower, and we attribute that thing to the latest code changes, which may or may not be true. But there is we try to find correlation when they aren't, or we are trying to improve the performances of our software, and then we do something because it's better. For instance, I don't know, you have a piece of code in Java and that's using reflection, and then everybody knows that reflection is slow. Then we remove reflection for this thing, and without measuring it, we decided that our code is faster. But this is just a placebo effect. We do something and simply believe that what we are doing it is helping, but without measuring it. And then I worked quite a lot also in performance analysis, and in that field especially I found a lot of patternicity and also overfitting. So we have some benchmark, and we try to overfit the performances of our software specifically for that use case at end, for that benchmark at end. So we are doing patternicity in that case, or we are doing even something that my friend Francesco Nigro call it bench marketing, meaning that there are a few benchmarks that are used for marketing, and we are trying to overfit our software to better perform in this. And even there, we interpret noise as signal. This really happened to me. I changed something in my code, and I measured it with a benchmark. I found a 3% gain, and then I was super happy of that 3%. And then Francesco came to me and said, "Okay, look, the noise of that benchmark is 5%. So you are just measuring noise." And if you torture the data enough, they confess everything. You can manipulate data in a way that as you want, and they will reveal what you expect at some point. And even worse, you can create rules, and overfitting applied to the rules, doing an extremely strong pattern matching on the rules, and these firebacks. This is also known as the Cobra effect. Anybody knows about this story? Yes. So what happened is that there was a problem of overpopulation of cobras in India in the 50s, and at that time the British government was in charge, and they decided to assign a reward to anybody who killed a cobra, okay? To anybody helped to reduce the overpopulation of cobra. And guess what? Indian people start breeding cobras. They have farms of cobra where they breeding cobras, so the cobra went even more and more. They kill them and they take the reward from the British government. And the British government figured this out. Of course, they decide abruptly to cut the reward. And at that point, the problem of overpopulation of cobra was even worse, of course, because you literally have these farms of cobra. So this is to say that we can create perverse incentives, and our patternicity make us to match those patterns created by these incentives and act accordingly. So my suggestion to improve from this situation is to measure everything. As I said, I worked on the performance analysis, but you cannot think that you do something and magically it's better. You need to measure, and you need to separate the signal from the noise. You have to be skeptical. You need to avoid the cargo culting, very important. You should never forget that correlation is not causation. You need peer reviews. And probably the most important thing of this slide is the latest tendencies to me. Embraces I don't know. Okay, say when you don't know something, just say I don't know. Don't try to find pattern where they aren't. This is another interesting thing studied in literature, is what is called the anchoring effect. What happens in our brain is that we see a value that, when we do a negotiation, for instance, that value becomes our anchor, and then our negotiation is anchored to that value. Okay, so if we see a price tag, we can decide that it's too expensive. But if we see a price tag that is the double and then a 50% discount, then our brain is anchored to the full price, and we think this is a great discount. And this has been studied, as I said, in literature with this quite famous experiment. What Devoxx and Kahneman did was that they asked people to estimate the number of African countries in the United Nations organization. But before doing this, they asked the candidate to spin a wheel of fortune. Okay, so the two things are clearly unrelated. But it happened that if while spinning the wheel of fortune, they got a higher number, the estimate was higher of this country, African country in the United Nations, than people getting a lower number were spinning the wheel. They were totally, of course, they knew that the two things were totally unrelated, but still, if there is a number, we tend to use it regardless. And this is also something that I found very common during doing performance tuning. I mean, if I have a software that performs in a given way, I am anchored to that initial value, and then if I can find a 5 or 10% gain, I'm super happy because my anchor was the initial behavior. But I could realize that you could be much faster. It could be, I don't know, 50% faster. And we don't try to make it as fast as possible just because we are using that anchor. And this anchor is also used for quality assessment, for instance. If somebody has to evaluate the severity of the priority of a bug, the first colleague that checked the bug and assign a severity to it, that level of severity becomes the anchor for everybody else evaluating that bug. So the idea is that to prevent this problem is to make an independent assessment. If I go to Jira and check a bug and I flag that bug as 0-day severity, then everybody will see the bug and decide it's super severe. Well, probably it's not, but the first assessment created an anchor, and maybe we want to avoid this. So again, make independent assessment, rotate roles if possible, and this is the last two things really work in my day-to-day work. Set ranges instead of single value, and try to do your estimation based on your historical data. This is something else that is very common too. It's what is called the sunk cost fallacy. In economics, the sunk cost fallacy is that effect where you put so many resources in something, so many money typically in something that you are doing, that even if at some point you figure out that it doesn't worth the money anymore, you should cut it, then you can't. The fallacy is that you put so much money in that thing that you keep putting money in it, even if at this point you know it is a bad idea. You are reluctant to abandon a wrong strategy when you have invested heavily in it, okay? And this is very typically in the financial world and in economy. So you holding stocks even if you are losing money, you keep pouring money into failing project, you keep developing products that are clearly of no interest, but you have put so many money on that you cannot stop, and you pour money into, for instance, underperforming ad campaign. And for us as developer, I believe that our biggest cost is time. I don't know if you ever end up in a situation like this. So I was doing this work with 7,000+ lines of code, 18 commit, and had 272 comments about this thing. Probably it was not a so good idea, but in essence, I spent 2 months doing this thing. I spent so much time in this thing that at that point my feeling was, please, I know this is shit, but merge it, because I don't want to throw it 2 months of my life away. Okay, so this is the sunk cost or time, of course, fallacy applied to our situation. I don't know if anybody find themselves in a similar situation, but yeah, probably a few of you. It's quite common for me. So, but again, here the idea to prevent a bit this problem is to fail as fast as possible. If you put in an effort, 2 months of your time, you don't want to throw it away. But if there was just a couple of hours, maybe it's okay to say, okay, it was an experiment, never mind. So file as fast as possible and use prototypes to do this. Look for feedback as early as possible, because this is also what happens to me. I do my work in my ivory tower. I spend days doing something without asking any feedback. And at some point when I'm done, I ask for feedback and people start saying, look, this is not the right thing. But I spend already too much time on it, okay? And then, of course, practice dog fooding. If you are a sliding door company, but your entrance is like this, probably is not a good idea. I mean, for instance, I do a lot of TDD, but not because I'm obsessed by test, which is also a good thing, but also because, I don't know, if I'm designing a new API and then I write test against that API, even before implementing it. And then while writing test, I find that that API is not so nice to be used. Okay, if I don't like it, probably my users will not like it as well, right? So this is dog fooding. I'm using it. I'm using the stuff that I'm doing to check if it is good or not. So this is why I said use test-driven development. Don't be attached to your code and be open to constructive critiques. This is another very common thing. I mean, if you find a critique in a GitHub comment, it's not a critique against you as a human being, you as a person, okay? It's a critique on your code, okay? So let's be open to constructive critics. Another bias is temporal discounting. So we tend to value the things in the future much less than the things that we have in the present, okay? So this is the reason why people don't save enough for retirement, or we pay crazy interest on our credit cards, or this is the reason why company favors things that can give quick payback instead of investing in long-term research and development, because of course research and development is something that will pay back probably in 5 or 10 years. So there is this temporal discounting thing. We're trying to give precedence to immediate rewards. And this is why, and this is have a lot of implication in software development. This is why we skip refactoring. This is why we defer automatic test. We choose quick and dirty solution and architecture. We don't write enough documentation, right? We don't think about security, and we delay the migration and tools update. In essence, temporal discounting is the main reason why we have technical debt. It's the main reason why all software at some point rots, okay? Because temporal discounting doesn't make us to think in the future, in the perspective of future. Okay, it works now, we are happy with it. But what about the technical debt? So this is a sort of critique of the ship now, fix later things, or move fast and break things, okay? Because if we do something now that works, but we have a lot of technical debt, we are just moving that debt in our future. And we will have to pay the interest of that thing in the future in an exponential way. So my suggestion to prevent a bit this problem is, in some way, try to make the future cost visible now. So use metrics to evaluate the quality of code, find a way to quantify the technical debt, and use a fixed portion of your time to do what I call code gardening. I don't know if you like the word, but I like to rework my code, refactor methods, make it more readable. If I see a comment that is too long, it means that the code, well, comments are good, right? But if the comment is too long and people decided to put a comment there, it means that the code is too complex to be read. So probably, yeah, okay, the comment is nice, but also try to make the code self-documenting, try to make the code more clear, try to make a way that that comment is no longer necessary because the code is self-documenting. Even because at some point you will probably change the code, but forget to change the comment, and then the two things becomes contradictive, and it will be a bigger problem. Okay, habits. We all have bad and good habits, right? But we have habits. We tend to keep our status quo. There is indeed this thing that is called the status quo bias. We tend to stick with familiar option, and while we should reevaluate it from time to time. If we have a default, we tend to keep it. We have some inertia. We are reluctant to change. That's the thing. This thing is also the main cause of procrastination. So we stick with same providers, we buy the same brand, we use outdated tools, and things like this, right? So this is also known in literature as Semmelweis effect. Anybody knows who Ignaz Semmelweis was? Okay, a few of you. So Ignaz Semmelweis was a doctor operating in Vienna in the first half of the 19th century. At some point, he became the director of a section of the biggest hospital in Vienna. And in that period, one of the biggest problem was called the puerperal fever. So it means that there was a very, very high fatality rate among pregnant women giving birth. Okay, and the fatality rate in his department of the hospital was 20%, which is crazy, meaning that one woman over 5 died while giving birth. Okay, so it was crazy. It was trying to find the reason. Okay, and the problem in his he found that the problem in his department was very simple at the end. The delivery room was next door to the obituary room, and doctor went from the obituary to delivery room without washing their hands. So he just said to the doctor, try to oblige the doctor to wash their hand. It was breaking an habit, and he couldn't. Okay, he couldn't for two reasons. First, because it's very hard to break an habit, even if like this. Okay, so doctor keeps going from the obituary to the delivery room with their hand dirty because it was their habit. And moreover, there is also another effect which is also applies to our work. Doctor couldn't believe, doctors are there to save life. Doctors are there in that case to help women to give birth or in general to save life. So they couldn't believe they were the cause of the problem. And this happens also in our work sometimes. Okay, we do something. For instance, I'm trying to improve the performances of my software. I change something, and suddenly the performances are much worse instead. Okay, but it's not me. It cannot be me. I mean, I'm there to make this software better, right? I cannot be the cause of the software going slower because I'm doing exactly the opposite job, or I'm supposed to. So there is this kind of resistance in our brain. At the end of the day, Semmelweis wasn't able to convince the doctor to wash their hand, incredibly, and he died crazy at age of 40 in an asylum. This is what happened. So please don't make this happen, the same thing also to our colleague. But in essence, we also have all, we are also driven by habits in our decision, in our day-to-day job. So we are familiar with our annotated framework, and we keep in using it even if it doesn't make sense anymore. We copy-paste code snippet from other project, even if the new project is totally unrelated to it. It serves a totally different purpose, so it was based on a different architecture, but the code is there, so why not to reuse it? We continue on growing our own tool. Everybody in his life has written at some point of his career an ORM, I believe. Because I don't like Hibernate, I will write my own ORM. So this is quite something also quite typical. We keep outdated dependencies forever, and probably there is still somebody still using Java 18 production, right? So we are really bound to our habit. So let's try to break this thing a bit. So let's try to force some deliberate evaluation, try to allocate a bit of our time to learn regularly. Let's try to encourage exploration and experimentation in our workplace. Try to check if we are using or abusing outdated tools. And that's important. Turn incident into habit-breaking situation. I mean, okay, shit happens. We make mistake. At least let's try to learn from our mistake. And once again, this is something that I also said for other biases. Try to rotate roles and responsibility, and document the decision. Okay, when you take a decision, do not only explain the decision, but also say why you took that decision, because you may want to reevaluate that decision in future. In future, the assumption under which that decision has been taken could be not true anymore, and you may want to change it. But to do it, you need to know why you took that decision at time. Framing effect. So framing effect is that people react in a different way to a particular choice based on how that choice is presented to you. Okay? And the framing effect is caused by another bias that we have, that is loss aversion. Loss aversion is something that has been also very well studied and documented. The problem is that our brain don't like losses. It don't like losses much more that it likes gains. So it means that if we lose 100 euro, it hurt much more. It hurt the double of the triple of gaining 100 euro. We are loss aversion. And this means that you can present an opportunity, a problem, a situation with two different frames, with a gain frame and with a loss frame. You can say, take this promotional save and you save $20, or if you don't take the promotional save, you will lose $20. And it's exactly the same thing, but framed in two different ways, on a gain perspective and a loss perspective, and our approach to the problem changes a lot based on this, okay? And of course, we can have exactly the same situation in our day-by-day work. If we fix this bug, we improve our stability by 10%. If we don't do this, we risk 1 in 10 users to experience a crash. Again, it's exactly the same thing, but framed into different way. And we react in different way based on the framing. And this is the same. Okay, I dropped a few examples there. There are probably many more. My suggestion about this is to frame the situation when taking a decision always in the same perspective. Again, you can have a gain frame, you can have a loss frame. First of all, try to figure out if how the problem is presented is in the gain frame or in the loss one. And if you have to compare two things, try to normalize the two perspectives, right? If you have a solution in the gain frame and one in the loss one, they are not comparable. So try to rephrase one of the two in order to be under the same point of view and take decision about this. Okay, so and when you are discussing this decision, another important thing that I try to do with my colleague is have somebody that play the devil's advocate. Okay, I want to implement this. Is it a good idea? Why not? What will happen if I do this? What can go wrong and stuff like this. Okay, so these are the patterns that I have. There are probably many more, but again, it's interesting to find our brains work in the day-to-day life decision and the similarities between those situations and what you have in your the work as a software engineering. Again, our brain is done in this way, okay? And it's not our fault. It's wired in this way. And by the way, it's wired in this way for a very good reason. Let me give you an example. Why we are affected by patternicity. We have a primitive man, we are in the forest, we see a shadow, okay? And that shadow may or may not be a tiger, okay? So if we use patternicity, we recognize the tiger and we run away. If we decide that, okay, this is not a tiger, but it was actually a tiger, then we are dead. Okay, so if we have patternicity, at most we have done a useless run. Without patternicity, we are dead. Okay, so we have patternicity for a very good reason. Of course, this applies to people lost in a forest, cavemen. This doesn't apply to this. Sometimes planes against us in the modern world, but our brain is evolved in that direction for a reason, and we have to deal with it. The only way to deal with it is to know that these things exist, to know that our brain works in this way, and apply some corrective action to adjust our decision-making process, knowing that we are wired in this way, okay? So what works the best for me is being a team player. Talk to my colleague, leverage the different skill, seek for advices, listen to listen. I mean, sometimes we listen, but we are not really listening. We listening, but meanwhile, we are already thinking to our reply, instead of really trying to understand what our friend, our colleague is trying to tell us. That's wrong. This is a bias in our communication. This is something that makes our communication not so effective, okay? Measure everything, as I said. try to, we are engineers after all, so try to measure everything and never stop learning. Enlarge your professional toolbox, okay? And when I say professional, of course, it's not Node.js. And this is to say that don't listen me, I'm biased too. Okay, thank you.
Thank you very much. I think it was a really interesting presentation. Even myself, that I understand probably 1% of what you are saying all here, I really enjoyed it. It was wonderful. Thank you.
Okay.
We do have 1 or 2 minutes for questions if someone wants to ask something. Otherwise,
yes.
Oh, okay.
So I'm curious about a bias that you struggle with a lot, where you know, I'm never going to fix this about myself. I have to build instead some habits to compensate for it. What are ones that you must warn your colleagues to monitor you because you keep making that mistake again and again?
So all those biases, I believe, applied to our day-to-day work, and I'm speaking about them because they affect me, okay? Then this is a very personal question, so I will reply. My biggest problem is probably the sunk cost or time fallacy. I mean, it happens to me that you know, I wake up with a clever idea, okay? I dreamed about it at night, and I decide, okay, this is super, and I come from, I don't talk about this with colleagues, I start developing it. And you know, I work remotely, I work from home, so I don't have many chances to...
Nobody tells you to stop.
Yes, nobody tell me to stop, okay? So these things can go forward for a day or for a week or for a month. And at some point, I push my work in the repository and people start commenting it. But at that point, it's too late. So that's probably the thing that affects me the most.
That's where the egoless programming from Jared
Weinberg
is
also,
helpful,
yes.
and all roads lead to Buddhism. Perfect.
Yes,
okay.
Yes.
Thank you very much.
Thank
you.
you.
Anyone else? Okay. Just a quick
another
one,
question,
because
sorry.
we are running out of time again.
Thank you, Mario, for the presentation. I would love to put the elephant in the room. Could you mention the 3 most important biases that you have found when using AI?
When using AI. Okay, the elephant in the room there is the confirmation bias, I guess. Because the AI is very condescending. I mean, it always tries to make you happy, and you look for a confirmation or your idea, and the AI want to make you happy. So this is also probably a framing effect thing. So my suggestion is, when you ask something to AI, don't look for a confirmation, because you very likely will have a confirmation. But this is not what you want. You want to challenge your idea. So try to avoid the confirmation bias. Okay, that's the things that, in my experience, affected me the most. Yes.
Thank you.